Back in the day, it used to be on clothing. Sometimes you'd see a little tag and it said, one size fits all. But I don't know if there were lawsuits, but now whenever you see one of those tags, it says one size fits most. And when it comes to NSX, we know that no two deployments are going to look exactly the same, but let's see what some of those sizes are that might fit most deployments so that we can anticipate what a good deployment might look like for our organization. Let's start with something small and relatively simple in terms of a basic deployment that isn't trying to handle too much all at one time. A small-scale NSX design can really just start with a few ESXi hosts in a single cluster. But what we have to remember is that this cluster is going to have to be responsible for hosting the NSX Manager virtual machine, hosting the vCenter Server Appliance virtual machine, hosting the Logical Router VM, hosting not one, not two, but 3 virtual machines, that's the NSX controller cluster, and hosting any virtual machines that are functioning as NSX Edge devices. And all of that is in addition to the infrastructure needed to support the individual VMs that this whole infrastructure is here to support, production and development and DMZ and all of those elements. This level of design, we're really expecting essentially for all of these to connect to a rack, and that rack to then be supported by routing out to the rest of the data center or to our internet topology. Of course, the biggest issue and the challenge in terms of scalability is the fact that we're going to have contention between the VMs that we're hosting and these management plane, control plane, and even data plane infrastructure elements of NSX. And let me just get in here early and say this early and often. One of the things we're often going to need to do is create reservations for the virtual machines that are running as NSX Edge devices, because those are real-time devices with a lot of real-time needs. Now, is there any way to make this a more scalable infrastructure? The answer is yes. One of the things that we could do is actually break this into 2 separate clusters. One cluster is there to host the management and edge resources, while the other is essentially a compute cluster. It's there for the purpose of the hosted virtual machines that are a reason for being. A lot of times people get frustrated or confused by this. So even though all these elements like the NSX Manager, the vCenter Server, control clusters, and edge components are all running in a separate cluster from the compute resources, they're all managed from the same vCenter server. And so objects like logical switches and distributed routing can be defined by a virtual machine in one cluster, the NSX Manager through vCenter Server, and then applied to the resources in another cluster, the compute cluster down at the bottom. This allows us to have scalability and to avoid some of the areas of competition. We have a much more discrete set of resources at the management edge cluster to balance, instead of it being a more complicated free-for-all with the compute cluster elements. And as we grow, we may go ahead and have multiple racks and different racks for different components of the cluster, and we can make that work without any problem. So that's a quick description of what the medium deployment model would look like. But let's take it one step further and take a look at an enterprise or large-scale deployment. So now as we scale out, we're going to add a few more ESXi hosts and put them in another cluster. And this bottom cluster is once again going to be the cluster to support our VMs, and therefore it's our compute cluster. But now we're going ahead and differentiating between our management cluster and our edge cluster. So those edge routers and firewalls and load balancers and VPN connectors are going to actually be in their own separate cluster, once again with a need to better manage those resources. And we may even scale this out so that there are multiple compute clusters depending on the types of resources and the locations where those need to be. So we could have 2 or 3 or 5 compute clusters as needed, all given access to the NSX resources through the management cluster and supported in terms of edge capabilities by the edge cluster. What about the networking to support that? It's going to need to be more robust. So it's in this situation that we start to see things like the leaf and spine infrastructure, which avoids some of the spanning tree protocol issues and allows for greater scalability. So my friend, as we conclude, what were the lessons learned here? As we move from small to medium to large deployments, we're seeing an increased number of clusters because clusters give us a great set of boundary tools to govern the behavior of the VMs running within them. So everything in one cluster, a management edge versus a compute cluster, or separate management edge and possibly multiple compute clusters. And then the network infrastructure to support all that can start as simple as a single rack connecting up to the rest of our network infrastructure to a much more complicated spine and leaf topology which allows for high-speed connectivity with all of our links up and running. By going through this together, you're in a better position to make smart choices when it comes to planning the type of deployment that you're going to be putting into your network. I hope this has been informative for you, and I'd like to thank you for viewing.